5 problems and 1 solution. And the solution is Feynman's technique. In this video, we are going to solve all of these problems using Feynman's technique. Let's begin. So the first integral is a bit easy. Yeah. Now for this integral, if we just introduce a new variable t over here, then that will make our life easier. So let's see how. If we define I of t as integral from 0 to 1 of x to the power t minus 1 by ln x, in this case, our aim is to find I of 1, which is the result. First of all, we will try to differentiate this. Now if we differentiate both sides in the world of t, we can just go inside the integral, since the integral is in the limits of constants and our differentiation world is t, but limit integral world is just x. And over here ln x is just a constant since we are differentiating with respect to t. So 1 by ln x, x to the power t. T is our variable where we are differentiating, and x is just a constant for that. So this is a to the power t times ln of a, and then this will be just 0 dx. Now ln x cancels out, so we have di by dt is equals to integral from 0 to 1 of x to the power t dx. Now this can be easily differentiated. Di by dt is equals to x to the power t plus 1 by t plus 1 going from 0 to 1. That's just 1 by t plus 1 minus 0. Okay, so now di equals to 1 by t plus 1 times dt. That gives us I equals to ln t plus 1 plus c. Now we know that this I of t is actually equals to ln t plus 1 plus c, and we need to find I of 1, but that's ln 2 plus c. Now how do we find c? Okay, so for that, just notice that if we have I of 0, that is x to the power 0 minus 1, that's 1 minus 1, that's 0. So integrand is just 0, and that's why overall integral is also 0. So I of 0 is 0 basically. So we will use that. So we will try to find I of 0, which is ln of 0 plus 1 is ln 1 plus c. Now I of 0 is 0, and ln 1 is also 0 plus c. That's why c equals to 0. So we get I of t equals to ln t plus 1 plus 0. Now we need to find I of 1. The answer of this integral is just I of 1. Yeah. So I of 1 equals to ln of 1 plus 1. That is ln of 2. And that's the answer. So the answer for this integral is ln 2. And that's how we solved it. Now go to the next problem. Let's try this problem. Okay. Now here is it. Okay, so for this problem, integral from 0 to infinity sine of x by x dx. So basically we just want to crush out the x in denominator, just like we introduced a t over here so that ln x will cancel out. Yeah, we will want to cancel out x, and there are two ways to do it. We can just introduce a t over here, and then differentiating also we can cancel x. Yeah, but when you go further in that, we will get a process or a step where we can't proceed further. So we'll go with the other way. There is also an other way where we can introduce e to the power minus 2x. This way also it works and it will be helpful. So this is what we are going to do in this problem, and let's see how it's helpful. So let I of t be this integral. Now if we differentiate, we get all of these will be constant since we are differentiating in the world of t. Then we will have e to the power minus tx minus x dx. Now the x will cancel out. Okay, so this integral is just a standard integral of e to the power ax sine bx form, and we know how to integrate that. Yeah. Now let me remind you the formula of integral e to the power ax sine bx dx that we learned in high school. This is e to the power ax by a square plus b square a sine bx minus b cos bx. Yeah, so this is the formula. Yeah, now we will try to use that formula over here in this problem as well, and that gives us di by dt is equals to e to the power minus tx by this will be a square plus b square. Yeah, so our a is minus t, so t square, and b is 1 plus 1, and then over here we will have what will we have, a cos bx. A is minus t, so minus t sine x, and then minus b 1 cos x. Yeah, so that's it. And now evaluate from 0 to infinity. Yeah, now at infinity e to the power minus infinity will dominate all of these. Yeah, and that's why it will go to 0 minus, at 0 this will be 1. Yeah, this will be e to the power 0 will be 1, and over here there's t square minus 1, which is constant. Yeah, and this also vanishes. Over here this will be minus 1, and then plus c. So we basically have di by dt, and wait, this minus sign, we have forgot this minus sign, so minus 1 is over here. So minus 1 okay, it goes to minus 1 times 1 by t square plus 1 plus c. Now we can integrate, and that gives us I equals to minus tan inverse t plus c. So now we have got up to this point. Now the problem is to find the value of c. Now to find the value of c, we need to go back to the problem. Yeah, now over here, if t is infinity, e to the power minus infinity will be 0, and so whole integral will be 0. So we will use that fact. I of infinity is actually equals to 0. Over here, I of infinity will be minus tan inverse infinity plus c, and that's minus pi by 2 plus c equals to 0, so c equals to pi by 2. Now since we have I equals to minus tan inverse t plus pi by 2, we can now find out I of 0, which is integral of sin x by x. Yeah, this will be 1 and it will vanish out. So I of 0 is the required thing, and tan inverse 0 is just 0, so 0 plus pi by 2, so the answer is pi by 2. So the answer of this integral is pi by 2, and that's it. So previously it was ln2, now it's pi by 2. Let's go to next problem. Let's go to this problem. This problem is kind of similar, not totally same though. Okay, fine. Now, for this problem, First of all, we can change ln x to y. Yeah, because that's just seems redundant for this problem. Okay, and then we'll have e to the power y equals to x. So e to the power y dy will be dx. And the limits will go from at 0, that's minus infinity, at 1, that's 0. Sine y by y times and then dx. Okay, so dx is e to the power y dy. Yeah, e to the power y dy. Now it seems like again the necessary change to make is just make it over here minus dy. Yeah, that will be helpful. Minus infinity to 0 sine y by y, and then we can just make e to the power dy itself. Yeah, dy, because here's minus infinity, so there will be minus something over there. Yeah, earlier it was infinity, so that's why we put negative sign, but here's already there's minus infinity, so no need of that. Okay, fine. Now put it like this. Now next thing is to differentiate. So di by dt is equals to integral from minus infinity to 0. All of these will be constant, and over here e to the power ty times y. Why? Because it's differentiated on the world of t. Now y will cancel out, and this one is an integral that we did earlier. Di by dt is integral from minus infinity to 0 sine y e to the power ty dy. The integration will be e to the power ty by 1 plus t square. Yeah, and then a is t a. Okay, so let me write it. E to the power ax by a square plus b square a sine bx minus b cos bx. Yeah, and then a sine bx minus b cos bx. Yeah, so this is it. Now going from minus infinity to 0, and this is di by dt. Yeah, now di by dt at 0, this will just be 1 by 1 plus t square. Yeah, and over here this is 0 and this is minus 1, minus at minus infinity this will go to 0. Yeah, so it's just minus 1 by 1 plus t square, somewhat same as previous. So we have till now di by dt equals to minus 1 by 1 plus t square. So I equals to minus tan inverse t plus c. Yeah, now again we can use minus infinity. Yeah, if t is minus infinity, this will go to 0. So we can use that fact, I of minus infinity equals to 0. So we get 0 equals to minus of minus pi by 2, tan inverse minus infinity is minus pi by 2, plus c. So c is pi by 2. Yeah, so I equals to minus tan inverse t plus c is just pi by 2. Now our required integral is when t equals to 1. Yeah, so I equals to minus tan inverse 1 is pi by 4 plus pi by 2. So I equals to pi by 4. That's the answer. And in fact, I need not have done it again. I just did it for the sake of doing. From the previous integral as well, if you just put t as minus 1, we will get the required integral that's there in the problem right now. Yeah, if you put t equals minus 1, this will be tan inverse minus 1. Yeah, that's minus pi by 4. Okay, so if t was minus 1, so don't we get but the limits are different, so that can be a problem because the limits over here are different. so it doesn't really give the required answer. This will not give you the required answer though, but these were somewhat similar. Yeah, that's fine. Okay, so this was somewhat similar problem, and the answer is pi by 4 for this problem. Answer is pi by 4. Okay, now let's go to next problem. Now let's go to this problem. ln2 pi by 2 pi by 4, and let's see what answer are we getting for this problem. Okay, so this one is a good, again, a nice problem. So for this one, what we can do is we can just introduce a t variable over here, so that we will have x square, which cancels out. Yeah. So let's have I of t as integral from 0 to infinity of e to the power minus x square sine of tx square by x square dx. Now if we differentiate, with respect to t, we will have integral from 0 to infinity of e to the power minus x square, that will be cos of tx square, and then dot x square by x square, and x square will just cancel out, and that will be a lot easier. Now what we can do is cos theta is just the real part of e to the power I theta, so we'll use that thing over here, e to the power minus x square, and then e to the power I times tx square dx. Now it will be a lot easier than dealing with the cos itself. So we have real part integral from 0 to infinity of e to the power x square. Let's put it here minus x square, because e to the power minus x square times some constant is a well-known result, and that gives us 1 minus it dx. Now we are using a well-known formula of integral from 0 to infinity of e to the power minus ax square dx. So this is actually equals to root pi by a times 1 by 2. Yeah, so this is a well-known result, we will use that. So this is di by dt equals to real part of 1 by 2 root pi by 1 minus it. Okay, so now we'll also now we will take the dt over other side. So di equals to root pi by 2 times real part of 1 minus it to the power minus 1 by 2, and then dt. Now we can integrate this. If we integrate, we'll have root I equals to root pi by 2. Integral can be taken into the real part. So integral of 1 minus it to the power minus 1 by 2 dt. Then we will have I equals to root pi by 2. This will be real part of, and 1 minus it to the power 1 by 2 by 1 by 2 times 1 by minus I. Yeah, plus c. Now 2 will cancel out, and then minus I will be 1 by minus I will be just I. So I equals to root pi real part of 1 minus it to the power half times I plus c. Now you can take I inside. Yeah, let me continue it over here. In this gap we had I equals to, but I forgot it, root pi the real part of 1 minus it to the power half times I plus c. I equals to root pi and then real part of 1 minus it to the power half times I plus c. Now we can take I inside. That gives us I equals to root pi, and then real part of, if it go to inside, it will be I square. I square is minus 1, so minus 1 plus it to the power 1 by 2 plus c. Yeah. Now this is we are close to the answer now. Now we just have to find c. But to find c, we need to know a case where we can find the value. So basically t is 0. If t is 0, we will just have sine of 0 is 0. So this will just be 0. So I of t will just be 0. Yeah. So we know that I of 0 is just 0. So that's why we will try to see what will we get. So I of 0 equals to root pi times real part of minus 1 to the power 1 by 2 plus c. Now I have 0 is 0, and then root pi of real part of square root of minus 1 is I plus c. Now this is a purely imaginary number, and its real part is 0. 0 equals to 0 plus c, that's why c equals to 0. Now we have I equals to root pi times real part of minus 1 plus it to the power half. Real part of minus 1 plus it to the power half. Over here, what we need is, to solve the problem, we need t equals to 1. Yeah. So I of 1 is the answer for us, and that's real part of minus 1 plus I to the power half. Okay. Now we need to express this in the polar form. Yeah, polar form will make the work easier to exponent by half. Now this is root 2 is the magnitude, and the angle will be minus 1 by root 2, and this is minus times plus. Yeah, so that will be around 3 pi by 4. So e to the power I times 3 pi by 4. Yeah, so these two are the same. Yeah, because it's in second quadrant, so, and that's just tan inverse minus 1. Yeah, so that's 3 pi by 4 to the power half. So this is root pi, real part of root 2 times e to the power I times 3 pi by 8. Now this is just cos 3 pi by 8 plus I sine 3 pi by 8. So the real part will be root 2 times, from there, that will be cos 3 pi by 8, 3 pi by 8. Now cos 3 pi by 8, wait, I forgot to take the root of root 2 as well. So if I take the root of root 2, that will be root of root 2. Yeah. So now cos 3 pi by 8 is also sine of pi by 2 minus 3 pi by 8. Yeah, and then that's 4 pi by 8 minus 3 pi by 8, that's just pi by 8. So it's root of pi times root 2 sine pi by 8. This is the answer. You can find the sine of pi by 8 as well from some other trigonometric formulas, which is sine pi by 8 will be root under 1 minus cos pi by 4 by 2. And cos pi by 4 is 1 minus, this is 1 by root 2. Yeah, cos pi 1 by root 2 by 2. So that's root 2 minus 1 by 2 root 2. Yeah. Okay, so that's about this integral. Now let's go to the last integral, which is awesome. This is from this is from black pen, red pen. Yeah, and this is awesome. Yeah, so It was copied twice. Okay, let's solve it now. So this one, about this one, the goal, the idea is to introduce a t variable in place of x, so that we differentiate. When we differentiate, we will have x over here, and so we can integrate this part. So that's the idea for this problem. So we introduce I of t as integral from 0 to infinity of e to the power minus x square cos of tx and then dx. Yeah. Now when we differentiate, we will get integral from 0 to infinity, and then e to the power minus x square. This will be when we differentiate, this will be minus sine tx, and then times x dx. So now we can integrate. This will be u, this will be v. So di by dt will be, first of all, we will just have sine minus sine tx, yeah, u, and the integral of this will be e to the power minus x square by 2. Yeah, is it or not? I don't think, or maybe that's not. If minus x square is y, we will have minus 2x, so minus 2 should be there. Yeah, that's fine now. And then okay, so this is single term, minus integral of, now derivative of sine tx is just cos tx, so minus cos tx times t, yeah, it's tx times t, and the integral is again e to the power minus x square by minus 2 dx. Minus minus cancels out, yeah, and then we will have di by dt will be, and now this is going from 0 to infinity. At infinity we will have e to the power minus infinity, which makes it 0. At 0 we will have sine 0, which makes it 0. At 0 this is just 1, it's infinity, it's just lying between minus and 1, so there's no problem. Both cases will go to 0. You can just take the limit if you are not sure, yeah. And then minus, we will have integral of, we will have t by 2 over here. We will have t by 2 over here, and then cos, and then cos tx e to the power minus x square dx. Yeah, and now this is the original integral I of t. So we have di by dt will equals to minus t by 2 times I of t. Yeah, let me check if I'm doing it right or not, just in case if there might have been some mistakes. Okay, I think that's going fine. Okay, now we can use a separation method. So di by I equals to minus t by 2 times dt. And if we integrate this, we will have ln of I will be minus 1 by 2 ln of t plus c, and that gives us I equals to, this will be e to the power minus 1 by 2 ln t, so that's t to the power minus 1 by 2, yeah, and then e to the power c, yeah, t to the power minus 1 by 2 times e to the power c. Yeah, that's it. And now we need to solve for c. Okay, so let's see which are the values that we know. Now if we have t as 0, this is just root pi by 2. Yeah, if t is 0, this will be 1, and e to the power minus x square dx, this is a well-known integral, that will be root pi by 2. So I of 1 is just root pi by 2. We will use that. So I of 1 t equals to 1, that's just root pi by 2 equals to 1 to the power minus 1 by 2 times e to the power c. So e to the power c is just root pi by 2, not inside the square root, the outside. Yeah, root pi by 2, fine. E to the power c is root pi by 2, so our I is 2 to the power minus 1 by 2 times root pi by 2. Now for this problem, our t is 5. So I will be root pi by 2 times 5 to the power minus 1 by 2. Let me check if that's the answer or not. But that doesn't seem to be the answer over here in this. Oh, wait. This is not LNT. This is not LNT. So this is not LNT. So that's the mistake. Yeah, this is not LNT. So this is actually t square by 2. Yeah. So this one is actually t square by 2. So all of these will change. And now this will be e to the power minus t square by 4 times e to the power c. Yeah. So and then when we have t as 1, I think I need to do it again. Yeah. So let me just go back and do it again rather than doing it like this. Just go to the point. Yeah, okay. So at this point we will have a t square by 2 plus c. Yeah. So I equals to a times e to the power minus t square by 4. Yeah. Now we know that if1 is just root pi by 2. We saw it. Oh no, is it if1? It's if0, sorry. Okay, it's if0, yeah? Why am I writing it if1? No, when t is 0, then this is 1. So that's why it is integral from 0 to infinity of e to the power minus x squared dx. This is root pi by 2. Yeah, so for that it should be 0. That means I of 0 is root pi by 2. Yeah. Okay, now when I of 0 is root pi by 2, so that's why root pi by 2 is a times e to the power 0. So a is root pi by 2. So now I is a is root pi by 2 e to the power minus t square by 4. For this problem t should be 5. Yeah, this one t should be 5. So that's why our I of 5 will be root pi by 2 times e to the power minus 25 by 4. That's the solution, and we have solved this problem as well. Now, yeah, we have solved all of these problems, and yeah, we are at the end of this video. Its solution was ln2, this was pi by 2, this was pi by 4, this was root of pi root 2, and then what was there? Yeah, sine of pi by 8. And this one was, what was it? We just did it, but I forgot. Okay, so root pi by 2 was there, and then e to the power minus 25 by 4. So we have solved all of these problems using Feynman's technique. Yeah, and I hope you enjoyed this video and got some ideas about Feynman's technique. Thanks for watching. Look forward to seeing you in the next videos.